Welcome to the Newfangled Workshop podcast. Before we get into it, let's hear a little disclaimer.
The views expressed here are those of the participants and do not reflect the views of the United States Military Academy, the United States Army, or the Department of Defense. Good evening, ladies and gentlemen, and welcome to the Newfangled Workshop. We're so pleased you've joined us this evening here in the North Country, just south of Albany. Well, I've got both Matthew and Stephen here with us this evening, and we're talking about that most wonderful of artistic ideas, and that's creating. Okay, I can't do this anymore. I can't keep it up. I absolutely can't keep it up.
At least you didn't say ideate.
Yeah. So yeah, the thing with whenever you're making something, like when you're a kid, right, you just grab a hammer, start making something, right? And that's kind of cool, and I understand it, and it's fun. But as you get older, you have intent when you make something. You are like, okay, here's what I want to make. And then before you grab the hammer, you make a plan for what you're going to do with the hammer and the materials and whatever other tooling you've got. So I figured tonight we would talk about sort of how you move from an idea to the start of construction. So I'm not talking about the ideas themselves, like where the ideas come from, outer space or whatever. A lot of people, there's a lot of artists out there that talk about that. And I do regard that as an important topic. But there's also this thing of, okay, now I've got the idea and I need to either communicate it to others or even just communicate it to myself. So with that said, I figured we would talk about the tools we use, whether those are anything from a pencil to SketchUp or something, and kind of how effective we find those tools to be. And I'll now cede the floor to my wonderful brothers for whatever kind of opening statement they would like to make when it comes to ideation and creation. Stephen, what do you think?
Oh, well, welcome. It's good to be here. Good to see you guys. Good to see you guys.
Good to see you too, man.
I think for a change, I'm not the southernmost participant. I'm up in Canada today.
What?
A road trip, right? So we're taking the cycle carts to an international event.
And, international, all right.
International. And yeah, so creating the cycle cart, that was a great example. I used many different methods for capturing ideas and committing those so that I could review them, revise them, and build stuff. So I've got plenty of input, and looking forward to chatting with you guys. Over to Matt.
Excellent. I'm Matt. I think I'm in the middle somewhere. I think Led is the most southern at this point. I'll be in the middle. Stephen's the most northern. I'm in Winona, Minnesota this evening, and this resonates a great deal with me. I come from a software background, spent many years writing code. And one of the things we say in that industry is the worst mistake you can make is when you start a project is start writing code, right? Like you shouldn't write code as one of the first steps in your process. Instead, it's much more important to have a set of specifications or a set of requirements that you're shooting for so you know what to code and what your parameters are. So I've always, don't code first is something I picked up from Joel on Software is an Interesting blog from back in the day, and I really appreciate his mentality of how to approach that. It's much easier to change a Word document than it is to change a dynamically linked library or a set of code that you've already written to do a thing. And so start a Word document if you want to write requirements for software. I personally find pencil and paper to be a great way to do things. And we'll get into the whole what are the right tools and stuff. But I'm excited about tonight's topic.
So I thought maybe we'd start by talking about depth a little bit. So one of the things that you decide at the beginning of a design process is how in depth is the design going to be? Like if I'm going to do a birthday cake, then the birthday cake, I'm going to choose an icing. I'm going to choose a diameter. I might not even need a sketch. I might just need a list of the various ingredients and what it is that I intend to do. So that'd be like the lowest end. And you go all the way up to, doing something complex like an engine. where every single part needs to be specified down to the last, couple of microns. And that's going to be a much different planning effort. So depending on what it is you're attacking, you're going to want to vary the depth of the design effort. And it's absolutely true that people can get stuck in a design loop where they're spending all their time designing and no time actually swinging a hammer. So at some point you say, well, I've advanced the design far enough to start pouring concrete, or nailing together boards, or baking the cake, whatever it is that you're intended to do. So I'm going to show an example tonight. I made a shed this last summer. Well, let me share my screen here. I think that my brothers have taught me enough that I'm going to be able to do this. So I'm going F11, and now I'm going up here to try to share my, oh man, it's just not happening, is it? So I got to hit share screen. I got to hit what it is that I'm trying to share. And then I got to share that. And then I got to hit F11. Oh, no, that didn't work. God darn it.
No. I have an overview of a picture. That was spectacular.
Okay, there, you got it now?
That's a shed right there. We've seen this shed in a previous episode where we talked about building permits and stuff. This was great.
Yeah, that's right. Well, actually, it was cool. That to sort of finish that story, I did have the building inspector come by just last week and approve the shed. Talk to me about hurricane clips and all that kind of stuff, which I thought was an interesting conversation to have about a 12 by 16 shed in your backyard. But it actually was very welcome to have a professional walk through it and give me his advice. So this shed right here, clearly that's not going to happen without some kind of sketches, drawings, etc. So I'm gonna. So how did I go about doing this? This came up out of a. Shoot. How do I? Okay, so I got to stop sharing. Okay, then I got to go over here. I got to hit escape to get out of that. Then I've got to go F11 again. All right, I'm getting there. And then I got to show you what it is that
Love it.
I was actually up to. Okay, now I'm going to share screen again. Here we go. Let's get to shed. So Matthew says he's good at software. That's like the opposite of me. I'm so like not really that good at software type of stuff. So here you're seeing all my IT skills fully exposed for the world. So that's the shed right there. So the tool that I used in this case to create the shed was SketchUp, and SketchUp's a pretty good tool. Because you can draw it in detail or not. So this allowed me to like click on a piece, and I click on one 2x4 and it'll tell me I got 33 8-foot 2x4s in the model right up here. And that was really useful for quantity takeoff. I wanted to know how many 2x4s I got or what types in the job so I can go to Home Depot and buy them. That was helpful. And this one also allowed me to really spec out in some depth what it is that I was doing with complex components. Like, so these windows, for instance, I really designed all the way, right? So those clerestory windows up here are made out of 5/4 board. That 5/4 board ain't cheap, and the glass isn't cheap, and trying to make each one of these and make sure it fits in there and doesn't leak when the rain comes down, that was worth my time. You can see right here, for instance, I was confident enough in my skills that I did not need to like draw every piece of fascia board perfectly. This piece of fascia board up here at the top, I'm just going to field fit that. Does not have to be drawn in detail. But that window, man, that's every detail of that window is down to the 1/4 inch. And that allows me to do stuff like, let's go over here and I'll show you what it is that I was trying to do with all of that. Where's my truss that I was just showing y'all? It's right here.
It's right there.
All right, so I'm going to do that. And I'm going to go F11, and I'm going to go up here, and I'm going to do a new share, and I'm going to share with you.
Oh no, we're seeing the window right now.
Oh, you see the window right now?
We see the window right now. It looks great.
Right, and so this window, you can see we're down to the 1/8 of an inch on that thing. And you can, this is a JPEG that came out of there. And I actually took this out in the shop with me. And that's how I ran the table saw to get all this right.
That's spectacular.
So that's all that's using. So that's the main tool that I was using is SketchUp. I also use pen and paper sometimes, and I'll show you one more thing from that, which is this guy right here. So let's see. Now I go share screen. I think I'm figuring this out.
You're getting closer.
I'm going to share the screen and F11 that thing.
Yeah, there you go.
So you can see this is also like pen and pencil, pen and paper here.
I'm thinking
Right,
you used a ruler to help you with this.
Yes, I did. I did use a ruler to help me with this, and I used a lot of dimensioning stuff. So there's a lot of tricks in the field when you're drawing this stuff, where you're like holding up a ruler and doing the whole thing where like the artist with the thumb, right? You're like doing the artist with the thumb and taking a bunch of measurements and putting them down on there. But so pen and paper I also think is really cool. But the thing about this drawing that you're looking at right here, while it looks neat, it has no dimensions. I could not hand this to the stonemason and have him start carving columns. I'd have to take it that next step. So anyway, that's some things about like how I go about it. And I was curious, Matt, Stephen, how is it you guys go from, the idea in your head to something you're cutting in the shop or whatever? Stephen, you were talking about your cycle cart stuff. A lot of parts in a cycle cart.
Yeah, 100%. 100%. So I think the what's the word I'm thinking? It really depends.
You're a little quiet.
Okay, let me get a little closer. It really depends on the revision that you're building, right? I think the first shed that you build, there's a certain amount of detail and a certain amount of characteristics you need, right? Maybe your first cycle cart, for example, right? But like if my buddy Jim went to go build that shed, he wouldn't need a plan. He knows how to build it, right? Because he's built like, I don't know, a bajillion, right?
Right.
Yeah, there's something to be said. So that being said, there's like a certain experience of fabricating similar things, which comes into play with the design process that you're talking about. And the other thing that I see that's very effective is prototyping, right? So I've seen people build sheds like yours. I think Jimmy Dykstra, the renowned maker, he was building a shed and he built a stick model of it, right? So he used basically tongue depressors, I believe, or something, or like modeling wood to do it. And there are videos on the internet for that. But I think most of the Boy Scout, Eagle Scout projects we've done, there's been a prototype involved. You build a popsicle stick version of your wooden structure or something like that. So love the shed project. Just think that prototyping is very effective for when you're doing, say, something for the first time or first couple times.
Sure. Sure. And it's almost like you're building it a little bit, once you're good, I'm not struggling with SketchUp anymore. I'm able to think as I'm doing it. It's almost like I'm taking the 2x4, you're cutting it to length and placing it, so there is a little bit of prototyping and doing a detailed model, I think.
Yeah. I'll hand off to Matt to see what Matt has to say.
I think Jimmy DiResta is the best, right? He's one of the icons in the world, and he has just amazing content. Somebody everybody should be following, I think. For me, I'll give you an example. 3 or 4 years ago, I started building small little 6-inch by 4-inch pencil boxes that I could laser engrave, and then has 3 sections in it. It's a very simple thing that you put on your desk. And so 3 or 4 years ago, my Instagram was just covered with pencil boxes. And a friend called me up over the weekend and was like, "Hey, do you still make those?" And I was like, "Only for the right people, right? Like I'll make them for the people that I care about." And so I was able to make one, and it took all of 3 hours, 2 hours out in the shop to throw one together. Found some scrap wood, cut. I think I used the tape measure twice, I used it to measure 6 inches, put a mark on a board for the miter saw. I measured another 4 inches and put a mark on the miter saw. And I never needed to measure again. Everything else was just eyeball and what we call relative dimensioning. So it just needs to be as thick as this board. So I use the board as the reference, and that's what I use to scribe out where the dados are going to go or where I had to put my rabbits in. So relative dimensioning, once I get into the project, right? So once I've cut the first 4 boards that are going to be the sides of the box, everything else is just based on making those sides even. And so if it's, 5 7/8, or if it's 6 1/8, I don't really care, right? It's like as long as both sides are exactly the right length, the same length, I should say, they're duplicated. So the experience thing I resonate very well with. The design thing, led, I think that one of the most underrated design tools is literally PowerPoint. And I think that just drawing rectangles in PowerPoint to get references of how big something is going to be, like moving to the 3D SketchUp model, can be pretty intimidating, right? There's a pretty steep learning curve initially to doing some of that CAD work. And I think SketchUp is probably a CAD piece of software. For me, the lower hanging fruit is something like PowerPoint. And one of the things that's really helped is Canva, right? I think in the last couple of years, Canva's caught the mainstream and people are comfortable drawing pictures and models in there a little more quickly than they are able to pick up something like SketchUp, or think about if you went to Fusion 360, or if you tried to go to SolidWorks and model.
SolidWorks rocks, of course, but it's so complex.
It's very expert friendly, is what I would say, right? And so
Expert friendly. I like that.
yeah, so there's like, yeah, it's expert friendly. Once you invest a couple of years in learning SolidWorks, you can do whatever you want in there, right? But it's an investment to get there. And then there's basic things like Tinkercad that Autodesk makes that's easy to mess around with. It's meant for elementary school kids, and you drag little gears around and stuff. Um, but I think there's different levels of the CAD work that you're doing. And I find initially when I want to do a cut list, or how am I going to cut up my piece of plywood, PowerPoint is plenty powerful enough for me to draw a 4x8 sheet of plywood and then add some lines for where I'm going to do my cuts and keep things complex enough for me without getting into the heavy lift of one of the CAD tools.
Yeah, I could see that. Stephen, are you drawing the stuff before you prototype it, or are you? I mean, you must be handing it to, like, if you're doing some sort of laser cut or something, you're handing it to the laser cutter somehow.
So usually, my preferred method is to use a whiteboard and to sketch out my ideas on the whiteboard. And some of them are terrible, some of them are great, right? And then I do a lot of erasing, right, till I get it to look like something that I like. And then I take a photo of it, right? So I'll take a photo of the whiteboard, and then if I'm gonna do something that I think needs a CAD precision or CAD work, I'll import the photo into Fusion 360, and then I'll drop my dimensions and my lines and my primitives on top of the drawing, and on top of the photo in Fusion 360. So that's kind of my process when I'm doing something that maybe first time, like these first time sort of things, right? And kind of maybe, or something unique, something new and unique. Yeah. And I chuckle a little bit. My buddy Chris is here in the room. He's a SolidWorks expert, hands down, right? And when you guys were joking about SolidWorks, he's like, it's simple.
Yeah, too easy, too
Yeah,
easy.
you just do you follow the curve of the inside radius and stuff. And so we'd like to welcome Led. I know Led's hosting tonight, but we'd like to welcome our very first podcast guest on. This is Chris. Stephen, could you introduce Chris for us and give us the 30-second rundown?
I'll let him introduce himself. He knows himself better than I do.
Hello, yeah, I'm Chris. I'm a SolidWorks expert, according to you guys, which I will gladly take. And I must say, actually, just from hearing what you were saying, I actually find trying to use SketchUp and Fusion actually really quite difficult, because my brain is wired to use SolidWorks. And that's kind of like, I've got myself a bit shoehorned that's all I know. And I can do something really quick in SolidWorks, but I struggle to do it in SketchUp or Fusion. Or
Yeah, I think guys going between AutoCAD and SketchUp suffer that way too. You know, like if you get the civil engineer who's an AutoCAD expert and they try to move over to SketchUp, or a mechanical engineer from SketchUp trying to move over to AutoCAD, you know, or Autodesk something, they get super confused, and you know.
Well, many years ago, I was fortunate enough to I was trained to use Pro Engineer. And it so happened that for the company who I worked for at the time, the Far Eastern companies preferred us to provide them drawings in the Pro Engineer format. And North American customers preferred the same, but to be presented in SolidWorks format. So I actually was taught through the company I worked for how to use both. But then since then, I only use 100% SolidWorks.
You know, are you taking the SolidWorks stuff when you're doing cycle card stuff? Are you taking the SolidWorks stuff and importing it into, you know, CNC or other 3D printing stuff like that to knock out parts, or are you then bending it in the shop yourself?
Well,
Go on, you go.
so Chris is a guest this weekend. He doesn't have a cycle card, right?
Oh, okay.
It's part of the support crew, I guess,
Nice.
and
I'm
all
here
like
for
that.
moral support.
His professional background, he makes electronic enclosures, I guess is the best way to put it.
Yeah, I work for a company that we do equipment for signals intelligence and spectrum monitoring. So it's electronic enclosures, PCBs, outdoor enclosures, radomes, arrays, outdoor mast mounting equipment, telecom stuff.
Mm-hmm. The stuff that the enclosures that the spiders get into and make unending trouble for technicians who are up on a pole, right? Isn't that like the classic thing, is that insects get into these boxes if they aren't tight?
It's quite surprising how something that's IP rated to say 66 is supposed to be fairly rain resistant, and yet when you do open it, you find there are bugs inside. We've had IP rated enclosures, and we found scorpions inside them.
But a scorpion's pretty big.
Yeah, so I don't know how they managed to get in, but yeah, it's quite revealing, because when we've had stuff serviced, you very gingerly open the hatch to see what might fall out into your hands.
Yeah, and this is sometimes up on top of a tower that's several hundred feet up in the air, right? And then you're finding things have climbed all the way up the tower to get involved in your equipment. Yeah.
Sounds perfect. So so Chris, what's the most challenging thing you've ever tried to draw in SolidWorks?
Well, we were talking about this early on in the drive up here. So I tend to not sketch something conceptually on paper anymore. I go straight into SolidWorks, but that's mainly because a lot of our equipment uses proprietary equipment from other suppliers. So we can get the 3D models for those components from the supplier, and then you can kind of tend to then design what we need to do around those already pre-drawn components or models. In terms of what's the most difficult was probably trying to reduce one of our products to make it lightweight so it could fit into a UAV. There's lots of challenges with that because you have such a constricted weight in the payload that it can take.
Yeah, I guess the UAV thing is all getting dominated now by, 3D. Everybody wants to 3D print components for their UAVs, for repairs or for, field modifications, all of that kind of stuff. And so far, I think it's mostly notional rather than production. I don't know anybody's like 3D printing on a production basis, but clearly there's a lot of drawing requirements inside of that, and for one thing or another. UAVs are pretty sensitive to very small changes in weight, right?
Yes, and power supplied to our equipment as well. Power is often limited to what we want and what we need.
Yeah, the way that I heard Chris talk about the project is that if you think in your SketchUp world, you go out to the warehouse and you find the thing in the warehouse, like you could import 1,000 different kinds of chairs into your SketchUp drawing. It's like Legos, right? You're finding the supplier has provided you the drawing of the thing that they make, and you're putting that into your drawing with some other manufacturer's thing, and you're doing Legos to put your thing together.
Yeah,
I sometimes worry though that limits that the wide availability of sort of other people's work on the internet might somehow limit creativity a little bit. In that,
well,
if I want to do a desk drawer, I just go find a desk drawer.
No, no. So let's hear what Chris says about this. When your manufacturers are providing you parts, is it like
well,
Legos?
it's interesting because you can get components directly from the supplier, the manufacturer, say Amphenol Soccerplex, or you can get components and parts that other people have drawn, say on GrabCAD, but you have to check what you download because invariably sometimes the models that other people have drawn might not be accurate enough. So what I found is that I almost have to go and find the data sheet for the component to check the dimensions of the part I've just downloaded are accurate to what the data sheet says. Otherwise, I'm going to handicap myself before I've even started designing something because I'm working with incorrectly dimensioned data. So there's a lot to be said for people that supply parts, but you really have to be careful where you get the parts from. And it's often wise to check that the part is dimensionally correct before you do anything.
Yeah,
Yeah, I guess there's a lot of free wrong stuff on the internet, right?
Yeah, yeah, exactly. That's it. There's a lot of free stuff, but yeah, it's wrong.
My
So
experience with that is Thingiverse, right? Doing the 3D printing out of Thingiverse, and you just download some STL files, and they describe it as one way you print it, and it doesn't work out the way that you had intended it, right? Like, they have to read the fine details, and scale that up 120% because I was wrong when I published it. I have to go back and read the comments a bunch and find out where the thing went wrong. So Thingiverse is a good example that of it's available on the internet for free with errors.
I
Yeah,
could give
yeah.
you a good example, a very good example of how SolidWorks helped outside of a work environment, if you like.
Yeah.
So a work colleague was having an extension built to his house. So I drew all the steel parts for the brackets for his roof that he needed. How the planning system works in the UK is that you have to lodge a planning application with the local county, and then you have to advertise that so anybody who lives around you can query it or disapprove of it or reject it. So it turned out that my work colleague's neighbour was concerned that the extension to his house would cause undue blockage of natural sunlight in his backyard. So it was like, well, okay, let's look how we can do this. So in SolidWorks, you can basically, we drew a rough outline of his house because that wasn't what was important. What was important was the dimensions of the extension that we could take from his architectural drawings. And then in SolidWorks, you can place that in a geographical location. So we knew by working out where the center of his extension was on the map. So then SolidWorks knows geographically where that extension is in the world. And then what you can do is you can run a simulation which models sunlight. However, you could have increments of 30 seconds if you want, but we ran a simulation of where the sunlight would be on that structure once every hour for 24 hours. And we were able then to create a simulation and ultimately an animation of the fact that the neighbor's backyard would not have any shadows created by the proposed extension. So the guy's objection to the planning application was actually overruled because we were able to prove that there wouldn't be anything affecting it.
So it did like a time lapse. You were able to do a time lapse over the full day. This is what it would look like with the shadows.
Yeah.
Right, and geographically positioned correctly for how much daylight there's going to be and what time of year it is, and that's awesome.
Yeah, that was probably one of the more I mean, everything's interesting, but that was one of the more challenging, interesting outside of work to do because it was just a fun, it was almost like a fun exercise, really. But it also served the purpose that we were able to help my work colleague get his planning applications, approved because we were able to disprove any appeals or objections to it.
And arguably that would be very difficult without software, right? Trying to do that by hand would be very challenging.
So this is an interesting comment that we talk about the basic building something, taking a hammer, building a shed or what have you, right? And in those terms, I usually think of using CAD like a drawing, like a dimensional sort of a 3D object manipulation of the physical object, the limits of the physical boundaries. But now CAD can go well beyond just the physical object, right? It knows what material you have. It knows the characteristics of the material. It can know something like the stress analysis. You could do a stress analysis of the structure, right? Now, what I found is very few people actually do this, right? And I don't know what you call them, extensions or advanced features of the CAD.
It smacks of effort, man. Who wants to do that? That's
Exactly.
Well, we do thermal analysis.
Oh,
We
right.
do
The
stress
heat transfer,
analysis.
yeah.
One thing that we did look at to do, instead of spending lots of money on a third-party test house, was to actually do simulation of vibration testing. That's an interesting one. You can do within SolidWorks, you can do toolpaths for CNC machining if you so wish. You can do photorealistic rendering, you know, and like Steve was saying, if you have a part, you can apply a texture to it to make it look like a material. And then when you apply that texture, then it becomes a thing with properties. So you can work out what its mass is, what its center of gravity is, its weight, and then you can even just run it through a photo renderer. So it then creates almost like a data sheet, product specification sheet representation of it without having to get photographers in to do photography of the finished product. We can represent it before it's even built. And that has actually caused problems because we've done that in the past where we've created a product and we've rendered it and it looks like an actual real thing. A salesman's seen it and thinks it's an actual thing, a product. He's gone out and showed it to a customer and said, hey, what do you think about this? We're saying it's only a photo render in computer space.
It's not a thing. Yeah.
So, you know, SolidWorks can do that good a job.
So I'll tell a very quick story. We were working on a room with some architects, and they drew up a picture of what the room would look like. So they had rearranged the whole room and how were the desks going to be and where were the TVs going to be on the wall. And they had used one of these texturing tools that you're talking about, and they had put in some orange carpet. And some executive with the group that we were working on saw the picture, said, this is exactly what I want the room to look like. And the room ended up having orange carpet in it because the executive had enjoyed the picture so much that the artist had simply just added some orange carpeting to. And I'm going to bridge to that. Led, could you reshare the SketchUp of your shed? Because there was a texturing thing that I didn't want to point out, but because you're my sibling, I feel like I need to. So could you reshare your shed? So as let's point, yes, this is perfect. If you zoom out just a little bit.
Wait, what do you want me to do? What? No, sorry.
Zoom out. I want you to zoom out just a little bit.
Okay. This is there you go.
Yeah, I'm thinking that the way you've oriented your shingles in this picture is not going to be very good for rain abatement.
No, absolutely not. Fortunately, the craftsman was able to identify that error before getting into the field. You can also see I left like the dimensioning lines in here because I don't care, right? Like you could hide that stuff if you wanted to. Boom.
No, but I'm just saying when I saw your oh, now we're going to have horrible roof leaks. This is terrible.
Sorry. Well, that's what I was pointing out right here. Like I got the flashing all wrong up here, right? Like that's.
But that wasn't important. But anyway, when you put the shingling texture on, which is a very nice shingling texture, I thought that was great. But it's off by 90 degrees, right? And that 90-degree off was, exactly what I think Chris was talking about, which is that the nice, easy texturing can also get you in trouble.
Yeah, and people come to expect that the rendering has some, direct similarity to the finished product. And when so in my day job, I'm working on very large civil engineering type of works. And you have to be ready to adjust as you go forward, as you learn more about the project, because you learn about the project as you're doing it. And the rendering is a beautiful dream, but those castles in the ether aren't the same as castles in reality, right? Like the bits and bytes of the fabulous castle might not work that way. So you got to be ready to actually bend some steel or move some stones too.
One of my buddies jokes about it. He calls it CAD vision, right? It's because it looks great in the CAD, right? but
Mhm.
in reality, it just doesn't turn out how you envisioned it. It's not that castle, right? So
Yeah,
become
100%.
Yeah. Yeah.
But this is where I something I want to look at more is that a lot of our electronics enclosures we actually have machined from a solid billet, and we give the drawing to our machinist, the company that does the lot of machining for us, and then they feed back and say, hey, look, I can't get that radius inside there, it's too deep, it needs to be a larger radius. And one thing I'd like to learn is actually to put our equipment or our enclosures through the toolpath module in SolidWorks and actually see what the problems are before we even present it to the person that's ultimately going to machine it for us. Because I think that having that knowledge would cut down a lot of time of backwards and forwards communication and, you know, can you just change this, or what do you mean, that sort of
Well,
situation.
that's the experience that tells you how far to advance the design before just handing it to the craftsman. You know, if Matthew's making a pencil box, you know, it doesn't take much of a design to have the craftsman just knock it out. And I think that sometimes the craftsman can get aggravated when the engineer gets too far into their world, right? So the craftsman wants to know what it is you're trying to do, and the design needs to communicate that. But at the same time, you don't want to be telling the craftsman how to hold the screwdriver, because that, you know, that's going to lead to, you know, an inferior product because of maybe a lack of commitment to the effort on the part of the craftsman, because they're just like, why am I even here, right, if they're going to tell me how to hold the screwdriver. So design software can be awesome all the way up to a full simulation, but the craftsman also needs space to do their part of the work. And so, Chris, you know, balancing that, right? I'm sure you have to do that in your work as well, because you don't want to tell the line chef how to crack an egg, but you still need to tell him how many eggs are in the omelet, right?
And I mean the working relationship we have with two separate companies that do our machining, the guys there are fantastic. You know, they aren't afraid to tell us if we're doing something wrong, and it's good for us to learn. So next time we don't make that same mistake. But yeah, we're fortunate that we have suppliers who are really good, really good.
Yeah.
I want to back up to something that for our longtime listeners who maybe heard episode 5,
Long suffering.
our long-suffering listeners. Um, in episode 5, we were talking about CNC work, and Steve and I have been having some conversations. One of the things I'm very intrigued by is a version of the design software that Steven's been convincing me to look at is VCarve's Makerspace version, right? Which is interesting, and it allows you to put parameters on for what you will accept for your jobs, right? Which I think sounds intriguing. Steven, do I have that right? You can say these are the tools that I have available to run your job.
Sure. Yeah, most of the SolidWorks and the Fusion and the VCarve, they'll have a tool library. If they're more advanced, they'll have a machine library,
Yep.
right? That the various machines that can hold the tools. And additionally, they'll have fixture libraries, right? So the vise that holds the stock in the tool, or maybe the 3-jaw chuck, or the 4-jaw chuck, or the dog on the chuck that's going to hold the tool.
Wow.
You know, you model that, and then you model the tool path like what Chris mentioned, and that tells you if there's interference and things of that nature, if the tool can reach that dimension, right?
So how far off are we from having, and you know, so let's close out the episode here. It's the time's spooling ahead. I want to close out the episode by looking into the future. And when we look into the future, what I'm seeing is it would be great to eliminate the. So right now, to be a designer, to some degree, you have to be a concert pianist on one of these design pieces of software, whether it's SolidWorks or AutoCAD or SketchUp or whatever. And I think that at least it makes sense to me to see a world where someone says to an artificial intelligence, "Hey, draw me a screw with this pitch," and it does that, lofting a helix through a profile or whatever the heck it is, the master cam move or that you got to make to actually make the part. So I don't see us as being very far away from talking to an artificial intelligence that's then actually doing the drawing for us rather than using the mouse and the keyboard. And Chris, I guess you're the master operator out there. What do you think? Am I very far from being able to just tell it, hey, draw me, the rim for a 2012 Subaru Outback wagon, in aluminum, and then, it does that.
Your timing is impeccable, because we had this discussion early on as a result of a message from our IT department. We're actually now very restricted in being able to use any AI in our design work, because it's exposing our designs to a third party where we don't know where that design goes.
Interesting.
So we've basically been told that nothing leaves the building in whatever form unless it goes to a supplier who obviously we have NDAs with.
Yeah, because then the AI learns what you're up to and it can do the same thing for other people, right?
If someone else has a similar search query, then yeah, it can present what we've designed to them. So we've got to be quite guarded with how we use, like what you're saying, emerging technology.
There was a story early days of the Chat GPT and the Open AI project that a Samsung engineer working on mobile phones uploaded some of the company's proprietary code to the third-party engine and asked, could you enhance this code? Could you minimize it, optimize it, do some functions with it? I don't know specifically what they asked for, but in the course of that, sent the proprietary code to the OpenAI engine, and bad things happened after that. Interestingly enough, many of the generative AI providers today have very specific SLAs and contract agreements about what they're going to do with your data, right? And so just like your Gmail, you probably don't know what the terms and conditions are on your Gmail, right? These OpenAI guys have and LLM guys have terms and conditions on their stuff too.
Yeah, the intellectual property stuff is a real thing, right? And who am I sharing my intellectual property with? I do think one of the things that's super interesting to me right now in the woodworking world, right? Like many of the YouTube woodworker content creators are, oh, look at the cool new CNC machine that I got, right? And they're all excited about their machine and they show you parts that they're making and stuff. But it requires a great deal of very local expertise and maintenance of the tools and stuff. I'm really radically intrigued by the send, cut, send model of part production. And I wanted to ask Stephen earlier in the conversation, Stephen, have you actually machined any of the parts for your cycle cart?
Yes.
Okay. And that was intentional, right?
I got help. I turned some axles, step down on the end of the axles to accommodate a certain size hub from a 1 inch to a 3/4 inch, I believe.
And I'm also working to reference previous episodes. When you helped Mac with his skid plate that you were showing off on the previous episode, that was also machined, right?
Fabricated is more accurate. There was no precision machining used.
Okay.
It was an angle grinder, like a medieval armor. It was built with an angle grinder and plate metal and a welder. Right.
So this is the case of the craftsman just getting after it.
Hey, there were no specifications on
here's
that.
some tools. Get a wrench, get a pair of vice grips, and grab that scudder and just start cutting, right? Yeah.
Sure.
Get out the tin snips.
Were you in Virginia at the time you were doing that?
Yeah.
Yeah, there you go. You just grab that scudder and start cutting. You're gonna get some respect that way, no question.
It's funny, we were at the cycle cart event about 10 days ago, and one of the fellows broke his strut on his front axle, and I had my welder with me, and he was able to weld it in the field and get back in business. So.
Nice. He was racing again in an hour. That's perfect. That's perfect. Well, on that note, I think we'll wind up our episode on design. It was a somewhat rambling conversation. This has never happened before in the history of this podcast, where we've just wandered around the design and construction landscape. But on this particular episode, that's what we did yet again. So thank you to all of our view. I'd like to use the plural viewers, but it's not clear to me that there are plural viewers. So
No. So I'll give a very brief update on that, and I have another thing too.
okay,
The last time
update.
I checked, episode 4 had 27 views, and so I think
Woo!
we've broken past the family barrier, right? So the family, right? So there has to be at least 1 or 2 people who aren't our family who have watched it. So
Yeah,
I
so
thought
we're not viral. We're extremely rare disease.
that's
So
correct. We're very
we're the
exotic.
equivalent of like an extremely rare disease.
Yes,
That's
yes.
nice.
Yeah, and then Led, I also wanted to help with the hosting a little bit. Chris, thank you so much for joining us. I understand these are very rambling conversations and might be a little hard to track because of the sibling stuff, but it's been great having you on. This was fabulous to have your expertise.
I actually looked at one of your podcasts with the bridge that you had, and I was talking to Steve earlier on. Take a look at the mathematical bridge in Cambridge, UK.
The mathematical bridge. Okay, excellent.
Yeah. It's actually a relatively famous bridge, and there are some the UK. There are some really neat mechanical and sort of, I'll call them whimsical bridges in the UK for pedestrians, and I think that's just awesome. I love looking at that stuff. Like that very famous what's that lift, the boat lift thing that's somewhere in Scotland that's picking up the boats out of the I just think that sort of stuff. I just love it. I just love it.
Yeah, that's the Falkirk wheel.
Yeah, that's right. That's right. And I just you know what? Things do not have to be efficient to be great. They don't. They can just be great. And so I just love that that particular wheel, the elegance of it, the beauty. It's just really something. So, well, at any rate, brothers, Chris, it was great talking with you this evening. And with that, we'll leave you hanging and wondering what is going to be on episode 7.
Led, I'm trying to get you to signal. You're supposed to clap your hands to let
Oh,
Steven.
okay. Here we go. Ready? Done.